This video and associated handout concerns using the NIST26 EI Demo with Spectra imported from vendor software. It is a part of a larger course on integrated deconvolution library searching with the new NIST26 software for GC/MS analyses. And here's the link to the course on my website. Evaluating the NIST26 EI Demo as delivered is the preferred approach. For evaluation purposes, most users will find the EI demo as delivered to be the preferred approach. It demonstrates very efficient chromatographic processing, deconvolution, and library searching without requiring changes to the installation. Vendor import of Spectra is still fully supported in the purchase version of NIST 26 with no significant modifications as delivered. But both are very useful to employ in your data processing, and in my routine work, I do both. I'll show you how to do it with the demo. So this is an optional configuration for vendor to NIST library searching, and some modifications are required. As delivered, the NIST26 demo is not configured to receive Spectra sent directly from vendor software, as I said previously. Vendor integration is provided as an advanced example, not as the recommended way for most users to evaluate the NIST26 software. It will require some modifications. There are really no major ones. It's just several steps that one has to go through. This tutorial demonstrates the procedure using the Agilent ChemStation software. Other manufacturers may require different configurations. After modifications, the processing of a file will be compared in the newly developed fully integrated mode versus the vendor import of Spectra for library searches. The new approach is much more efficient in my opinion, but vendor import can still be very useful. In most of my videos with associated handouts, the video really stresses the majority of the important information, but due to this topic, you'll have to use the handout to carry you through step by step how to make the necessary modifications. I've listed it somewhat in an outline form here, so I will not cover this outline, nor will I cover the slides. You'll have to look at it later, but I will go through and show you some of what I think are the key ways to modify things and then give you a demo of the software to compare both the vendor import of the Spectra versus direct processing using the chromatogram. I want to show you some of the basic changes I made in a few slides to give you an idea of how you edit things. So we'll go and find a file. I want to first edit the macro, one of the macros, so we'll go take a look at it. So we'll go to where the macros are part of the Agilent software, so they'll be at the top of the C drive, GCMS, and they're in these MSEXE type files. One of them I needed to modify here was called libsearch. You can see they're all macros. It's good to show the file type. So if you don't show the file type, because you need to maintain the file type when you edit it. So what I usually do is take a look at the view. We'll do detail, but then show. Make sure you show the file name extensions. So you make sure you do not change them by maybe inadvertently changing it and save it as a text file. So here's the libsearch.mac. I made a backup because the problem was in the Agilent software, it needed something called PBM search to work, but it needed what was in the libsearch Mac, not what was in the current PBM search that came with the system. So I had to go in and change that and edit it and resave it as PBM search match. But there really wasn't anything to edit here. These are all open. You can open them with Notepad, but I didn't really need to open that. I just really needed to rename it. And when I got through, I took the backup and turned it into PBM search.mac. And then the software would open properly and send something to the NIST program. So that was one thing I changed. The other, probably one of the biggest things that I changed, and the one that you have to be the most careful about, is to go to the C drive, go to Windows, and this is a protected area on the hard drive within the Windows software, and we need to edit something called win.ini. And you can see, usually when I start changing these things. I always save an old one in case I need to go back, in case I had problems. So I needed to edit this win.ini, and again, it is a configuration file here. It's not a text, but it is editable with Notepad. And what I did was I had to go back and change the folder because I had to change the folder names from the demo to make it work with this vendor software download or imported Spectra. So I changed all of these, including the AMDIS that comes with the program, to this NIST MS search. And when I did that, I tried to save it after I edited it here. And when I saved it, it said, well, you can't save it on this part of the computer. So I saved it somewhere else. And then after I saved it there and made sure the editing was all right, I dropped it in here and it would let me overwrite it, though it warned me this is a protected part of the computer. Do you really want to save this? And I don't know if it'll cause you problems. I have administrative rights on my computer, but that might be the only problem you'll have editing this file and saving it. So that's one of the things. Another thing that I edited, let's look at another one. There's another file that's very crucial in here, and it's within the NIST software. So that's, I had to change the NIST to NIST DE, which abbreviated Demo EI. So I named it that to be consistent. They usually are 6-letter names for their file folders. So I just kept the same format. And then you go to MS Search, and then you had to edit auto imp.msd. You'll notice this is a MSD file, but again, you can right click it and it is open with Notepad. This was not what came in this file as installed by the software. So I had to paste this particular address in. And this tells the computer when you send something, this file, if you look at that text, will say where to actually put the MSP, the actual spectrum that it will import. It's a temporary file you really don't see, but this tells it where to go. So I had to save that and I left it as an MSD type file. Make sure you don't change the extension for the files. There was one other file in here that's also very important, and it's called NIST MS $. So let's see if we can find it. Here it is here. Originally, that was called a very long name, and it wasn't compatible, and it can't be NIST MS .exe, and there's a slide in the stack that tells the difference. But I renamed that executable, which I gave in the handout, to this NIST MS $exe, and that's where Agilent expect the file to be to open. So when you're in Agilent software, it automatically opens this file, and if it doesn't point to the right address, then it can't open. So that you cannot change that in the Agilent software. Thus, you have to change it in the MS Search software from NIST. I think there's just one last file that I thought was worth mentioning. There's a file in here called INIT NIST. They were called NIST INI. NIST. I can't remember. There it is. NIST MS.ini. When you first open the NIST software the first time, it wants you to point to where the libraries are. We will point to them being in that folder that I just showed you, and it talks about that in the handout. But if you want to change it at a later date, and it talks about that handout because you want to change where your libraries are, or you really pointed to the wrong place, then you can edit this ASCII file. Again, it's an INI file configuration wise, so don't change that. But you can open with Notepad and you can change where the library is located or where the software expects it to go. So these are pretty much the basic operations. The only other thing was if you come here to the programs and you look at the programs, it would be under NIST Demo. You can see that now these are no longer showing their icon. That's because we changed the address and they will not work anymore. So what I did was I went to the C drive. This is the easiest way. There's lots of different ways to do it, but this is one of the easiest ones. So we'll get on the top drive, we'll go to our folder, we'll go to the MS search, and we'll go to that NIST again, ms $.exe. And what I did was I right clicked on it and said show more options. I said send to, and I sent it to the desktop to create a shortcut. I just wanted, you could put it on your taskbar, you could put it on lots of different ways to do this. You could fix the group if you wanted to, but this is the easiest way. And then I had a way to access it on my desktop. Usually the program opens within the Agile, but you might want to go in there directly at times. So put yourself a shortcut somewhere that you can find. So those are all the basic types of changes, but they're discussed in detail in the handout. I want to do a quick demonstration of the software, comparing the vendor sending the spectrum to the NIST search versus the internal deconvolution library searching in the chromatogram window. So let's open data analysis first. And we will be using a Grove file that's a demo file that came with the system. You can find it here in NIST and it's 32 tutorial grove.d, and it's a NIST file. So with a spectrum, if you've never used ChemStation, you just right click and drag. I want to do an average there, but you can see there's a lot of chemical noise here. This is 49 and 84 is from this methylene chloride tail. So you need to background subtract that. So I took the average over some background before it and say subtract. Now we got rid of a lot of bad chemical noise there. So to get that to go to the NIST search, click the bottom window, double right click, and it should open the window for you and do the search. But that assumes you had everything set up. So let's check our setup before we do some more work. We need to be using an EI normal search. We need to do a full spectrum search. We need to do a default on the pre-search. The pre-search gives you candidates, so it greatly speeds up the search process. So you always need to use that. We need to select our libraries. We had the main lab comes with the demo software, and it's 2000 Spectra, not many. And then I have these other libraries that you downloaded from the internet. You can use any, and I say that again, any NIST formatted library here, an old copy of the NIST distributed one that you bought, a Wiley library, Wiley specialty libraries, anything in NIST format, and even user libraries. And that's under Spectrum search here. And that's 60,000 Spectrum. If you wanted to do a structure search, you need to bring in the structures, and I'll use the same libraries, but you can see not every spectrum has a structure. We've only got 37,000 here. So that's good. We'll set up the automation, automatic search on. So when it comes in, it automatically searches, and that's done. This won't show up on here in the default version. I got that by right clicking, going to properties, and say structure on plot. And you can reformat any of the windows you want to, etc. You can see when I did that search originally, I got 100 Spectra up here because all the settings were already correct because I'd set it up before. And at the bottom, it tells you the type of search. It did EI normal and it displayed EI normal. So that was all good. So it was actually okay as is. We'll go to chromatograms. That's the other window we're going to use where all the processing occurs internally. So you don't have to send it to the program at all, and we'll come up to File, Analyze EI Input File, just so I can get at the setting. We're going to do Analyze No RI, and then we're also going to set the libraries, being Main Lib, BB, so the same libraries we used in the other, the same 60,000 Spectra. So that was fine. I just want to make sure everything was set up right. And so that's pretty much it. I'll cancel out of this because I don't want to do that search yet. So and that being said, we've got all of the settings. The only other one here, if when you get the results here, you won't have the spectrum shown or the structure shown at the bottom, unless if you go to properties and you say structure on plot. And I will say okay, because I want that. So to display this when we get the results. Well, pretty much all the settings are set where we need to do our searches. So let's go up and save our configuration. So we'll go to File, Save Configuration, and you can save it anything you want to. We'll call it JL underscore default, and it'll save it as an INI file. And then if you come back in at a later time and you're not sure if the settings are right, you can just go File, Restore Configuration, and pick it, or it'll be one in the list here, one of the more current ones. So we're all pretty much set up for what we want to do. We'll go back one more time to show you one more feature. Here you can go and click on this arrow at the top, which says switch to caller. That'll switch you to the program it came from. So we're back there. Again, I'll just go ahead and double right click and send it again. And you can see it searches fairly quick, these 60,000 spectra. So that pretty much shows you how it works. And then if you go to the bottom, you can left click on the first one, and you can use the arrow keys on your keypad to step up and down to look at the different possibilities. A lot of them might be undecane at the top, so if you want to, you can get rid of duplicates by clicking on this best matching only. You can see we went from 100 to 54, so it got rid of a lot of duplicates. I usually keep that off initially because I want to see everything, because some of them will have identities, but they won't have a structure. But if I go to another one that's a good fit, it'll be the same thing with the structure, because you only got this partial library right now. So that's how that works. So pretty much done with that. Let's do chromatogram now. We're going to do the same file. We're going to say File, Analyze EI Input File. It's Analyze No RI. We're not going to do retention indices because we don't have a retention indices ladder. And we'll go pick the file and same one. I navigated to the same place, NIST AMDIS 32 tutorial. Pick that same file and say Open. And now we're going to start the processing. So, okay. And it takes essentially about 3 or 4 seconds. And look up the top. How many did it search? It searched 61 things in 3 or 4 seconds. So very, very fast and efficient. What you'll notice in the bottom, though, you only have the best hit in this window. If you want to get more information, you have to get other possibilities. You have to send it to lib search. So one thing that I want to do, I want to get rid of some of these small peaks. You can sort, the abundance is up here. So the biggest peak is by default 100% abundant. So I'm going to sort by abundance. Now I've got 100 at the top. I'm going to left click on 100, hold down the shift key, and I'm going to go down to 1.10 and say Joe selected. Now I have them all, got rid of a lot of the small peaks. I want to resort on retention time because I want to see things from early to high retention time. So I'll just click on that twice. And when I click on it twice, now I have the earliest one in the other window. So everything's been identified now. If you want to see something, you can just click on the little dot which is its relative abundance, and see what it is. You'll notice here that you probably wouldn't have gotten this manually as easily because they're not resolved. But this also deconvolutes things to get separate peaks from one another. It takes all the background and does all the searches for you automatically in that 3 seconds. So it almost took you 3 seconds to do one manually while it did all of them here. So I'm going to click and say show all to go back, undo zoom. And I'll send this same spectrum over that we sent before, and I'll go down to the bottom. I've selected at the top. You can see it's in blue on the bottom. I'll right click and say library search. Now it sends it to the lib search window. So just instead of just getting one result, we get a bunch of results. So you can, again, left click and use your arrows on the keypad to step up and down to see the other possibilities. If you want to get rid of some duplicates, go to the best matching only. So I think that really gives you a fair comparison. And in general, I prefer initially just to use the very fast deconvolution library searching within the chromatogram window, but I still like to have the option of doing manual background subtracts and looking at the raw data in the vendor's software. So when you purchase the software, you won't have to do all these modifications to get it to work. It'll come with something that's easily interfaced to a vendor import for the manufacturer of interest to you. So I hope you found this modification of the demo so you could test it yourself useful. And I hope you found the comparison giving you the idea of what the pluses and minuses are of the different software parts of the system, how you can search, whether it be vendor input or you just do it automatically now with this new chromatogram search that was only developed in NIST 26. So good day.